Okay, so let's talk about domain and range of inverse functions, but without graphing them. How we can use the original function to help us find the domain and range of the inverse. So here's our original function, and we're going to invert it. Before we do that, though, we're going to set up our domain and range. Do you know what the domain of this function would be? Because it is a parabola. Do you know them well enough to be able to tell the domain by looking at it?
All real numbers?
Yeah, it's going to be x is, however your teacher gets you to express that, but it's the element of all real numbers. It goes forever. The range. Are you able to tell the range? And there's two really key pieces for the range of a quadratic.
Yeah, the vertex.
Yeah, the vertex is important, and specifically the y value of the vertex. And actually, and usually I think we put this, did I put this in green? I think I normally put this one in green. The a value is also really important. And what's important about it is whether it is a positive or a negative a value, because that tells you which way essentially it is opening. So our range in this one, because it's positive, it's opening upwards, okay? So we know that it's going to exist above whatever the y value of the vertex is, which is negative 10. So our y is all real numbers such that y is greater than and equal to negative 10. So it exists just above that, okay? So if we were to do the inverse of this function, what we do is kind of replace this with the value of y, and then we flip it. So then it becomes x is equal to 2y plus 6 squared minus 10. Now, normally with the inverse function, we would go through all of the work of setting this equal to y, and it would be some root function with our values kind of changed. But instead of going through that and then graphing everything, what we can do, is they're only asking for a domain and range, we can know that essentially these two ideas are going to switch with our inverse function. They're going to invert, you could say. So we'll write it in blue. The domain of this function will be x such that x is greater than and equal to negative 10. Okay, and the range will be the element of all real numbers. Y is element of all real numbers. Okay, so keeping that in mind, here's a reciprocal function. Now, reciprocal functions, their parent function looks something like this, right? We have existing here and here, where we, on our x-axis, we do not touch, so we're not equal to 0 here, and we're not equal to 0 here. I'm not sure if you guys have talked about this, but when this moves, okay, one way we can find out where the restriction is without really having to graph it, and I know I drew a parent function so we know, is when we're dividing, we essentially can't divide by 0. The bottom of this function cannot equal 0. If it does, then if you put it in your calculator, you get an error. It's called undefined. So in order to find out where the restriction is to this, I'm going to take just the bottom of the function and I'm going to set it equal to 0, okay? And that's going to tell me where it's called a vertical intercept. It's going to tell me where the vertical intercept is. So 2x minus 4 equal to 0, okay? In a normal one, if I have 1 over x, I would say x cannot equal 0. And that makes sense because our vertical asymptote, our vertical restriction, yeah, is at 0. It can't be equal to 0. So here, we bring forward, we get 4 is equal to 2x, and then x is equal to the value of 2, okay? So our vertical asymptote in this one is where x is equal to 2. So I know I said we didn't want to graph it, but I want to give you that idea. I wouldn't have to graph it because I'd have an idea of what this does, but essentially at the value of 2 is where our asymptote is, okay? So our vertical restriction, and it essentially doesn't exist there. So in terms of making our domain is x such that, so x is every real number, such that x cannot equal the value of 2. Okay, that's our only restriction. And our range, we already know, is very close. Our horizontal asymptote doesn't change. Okay, so x cannot equal 0 for our range. Okay.
Why?
So
no.
Oh, sorry. Thank you. Good question. You're right. That should be a y. No, why is it? There we go. Okay. So our inverse of this function, again, we just switch our x and our y. So x would be equal to 1 over 2, and then y here, minus 4. And again, we would normally go through the process of setting this equal to y. But if we just want the inverse of the function, the domain or range of it, I should say, we essentially just invert these two. And using that domain and range, I might be able to draw my function without having to go through all this work. I now know that my domain is going to be x such that x does not equal 0, okay, because that's what the y was before. And our range will now be y is all real numbers such that y, let's do x again, cannot equal 2. So if y can't equal 2, let's see if I can kind of mentally picture this out. Here's our coordinate grid, okay? Y can't equal 2 means our horizontal asymptote has probably moved up here, okay? Where our vertical asymptote, I can do that in red, is at the value of 0. And our function is probably still doing the same thing where it kind of runs along these two lines, okay? So that's kind of the idea behind it. But as long as you can figure out the domain and range of the original, you can invert them to find the domain and range of the inverse function.